Hello everyone, I am Prakhyath, Assistant Professor, Department of Mechanical Engineering, AJIET Mangalore. Today I am going to discuss about Module 3 of Fluid Mechanics, that is Class 7, continued portion of Fluid Dynamics. In this video, I am going to discuss about pitot tube and its related problems. So what is pitot tube? So pitot tube is a device used for measuring the velocity of flow at any point in a pipe or channel. So we used venturimeter and orifice meter to measure discharge of fluid through a pipe. So that is, those are used to find the Q, that is discharge of fluid through a pipe. Now pitot tube, it is different from venturimeter and orifice meter. So it is a device used to measure the velocity of flow at any point in a pipe or channel. So by knowing velocity, we can calculate discharge indirectly, that is Q equal to A into V, that's the area of cross section multiplied by velocity. So area of cross section, that can be obtained very easily. By knowing diameter, we can calculate area of cross section. Upon multiplication of velocity to area of cross section, we can get discharge, that is Q. It is based on the principle that if the velocity of flow at a point becomes zero, the pressure there is increased due to conversion of kinetic energy into a pressure energy. According to Bernoulli's principle, total energy remains constant. So what is total energy? Total energy is summation of pressure energy, kinetic energy and potential energy. According to Bernoulli's principle, total energy remains constant. So in pitot tube, the kinetic energy or velocity velocity of flow at a point becomes zero. Velocity becomes zero means kinetic energy is equal to zero because it is V squared divided by 2g. So when kinetic energy becomes zero, the pressure energy increases to maintain total energy constant. So according to Bernoulli's principle, total energy should remain constant. To keep total energy constant, when kinetic energy becomes zero, pressure energy increases. So that is the principle of pitot tube. In its simplest form, the pitot tube consists of glass tube bent at right angles as shown in figure. So pitot tube consists of one small diameter tube that is bent at right angle or 90 degree. So you can see the diagram or schematic arrangement of pitot tube. So fluid is flowing. There are points 1 and 2 and small letter H, that is the rise of liquid level in the pitot tube above free surface, and capital letter H. The lower end, which is bent through 90 degree, is directed in the upstream direction as shown in figure. The liquid rises up in the tube due to conversion of kinetic energy into pressure energy. The velocity is determined by measuring rise of liquid in the tube. So when kinetic energy becomes zero, pressure energy increases. So when pressure and energy increases, as a result, the liquid rises in the pitot tube. You can see the rise of liquid, that is by amount small letter h above the free surface. We consider 2 points 1 and 2 at the same level in such a way that point 2 is just at the inlet of the pitot tube and point 1 is far away from the pitot tube. So you have to consider point 1 and 2 in such a way that point 2 should be at the just inlet of the pitot tube and point 1 should be far away from point 2 or inlet of pitot tube. But point 1 and point 2 should be at same level. So it should be on same line. Let P1 equal to intensity of pressure at point 1, V1 equal to velocity of flow at point 1, P2 equal to pressure at point 2, V2 equal to velocity at point 2, which is equal to 0. Now velocity V2, that is equal to 0. Can you guess what is the reason? So velocity 0 means that's the stagnation point. What is stagnation point? So at stagnation point, the fluid, whatever the particle that is moving, that sticks to the wall. So same thing is happening here also. Same concept you can apply to pitot tube. At the inlet of the pitot tube, the fluid enters. So it sticks to the wall as there is no outlet for the pitot tube. So as a result, the velocity that attains or it reaches zero value because the fluid particle that is going to stick to the wall. So there's a principle. Because of that, V2 equal to 0. So H equal to depth of tube in the liquid and small letter h equal to rise of liquid in the tube above the free surface. Applying Bernoulli's equation at points 1 and 2, we get P1 divided by rho g plus Z1 plus V1 square divided by 2g, that is equal to P2 divided by rho g plus Z2 plus V2 square divided by 2g. but Z1 equal to Z2 as points 1 and 2 are on same line and V2 equal to 0. So I discussed about these points 1 and 2 that should be considered on same level. As a result, that is the elevation Z1, Z2, those are same. So Z1 minus Z2 that is equal to 0. And V2 equal to 0 because it's a stagnation point where velocity equal to 0. So P1 divided by rho g, that is a pressure head at point 1 equal to capital letter H. You can see there in diagram. And P2 divided by rho g, that is equal to pressure head at point 2, that is equal to small letter h plus capital letter H. Because when velocity becomes 0, pressure energy increases. As a result, there is a rise of liquid level in the pitot tube. So it is a summation of rise of liquid level plus capital letter H. Substituting these values, we get capital letter H plus V1 square divided by 2G, that is equal to small letter h plus capital letter H. So in place of P1 divided by rho g, we have to substitute capital letter H, and in place of P2 divided by rho g, we have to substitute small letter h plus capital letter H. But V2 square divided by 2G, that is equal to 0 because V2 equal to 0. There is kinetic energy at point 2 that is equal to 0. So H plus V1 square divided by 2G, that is equal to small letter h plus capital letter H. Now we can cancel capital letter H. This is common on both sides, right hand side and left hand side. So remaining term, that is V1 square divided by 2G equal to small letter h. So h equal to small letter h equal to V1 square divided by 2G, or V1 square equal to 2GH. So taking square root, V1 equal to square root of 2GH. This is theoretical velocity, that is V1 equal to square root of 2GH is theoretical velocity, but actual velocity is given by V1 actual equal to CV into square root of 2GH. Now what is CV? CV is coefficient of pitot tube. It is similar to actual discharge and theoretical discharge, that is ideal discharge. So I used CD there, there is a coefficient of discharge. So in order to get actual discharge, that is Q actual equal to CD into Q theoretical or Q ideal. So I have to multiply CD, there is a coefficient of discharge, to ideal discharge, that is Q theoretical. So Q actual equal to CD into Q theoretical. Same way here also, theoretical velocity and actual velocity. So in order to get actual velocity, we have to multiply by some coefficient, that is here CV into theoretical. So here also same thing. So V1 actual equal to CV into square root of 2GH, where CV equal to coefficient of pitot tube. Therefore velocity at any point V equal to CV into square root of 2GH. Now static and stagnation head. So you can see the diagram. You have to remember to draw this diagram. There is a fluid is flowing with the velocity capital letter V. There is a stagnation point. Hope you know what is stagnation point. The point at which velocity is 0, and pressure corresponding to stagnation point, that is called as stagnation pressure. And static pressure, I'll define static pressure and stagnation pressure in next slide. So stagnation pressure is the pressure which is achieved when flowing fluid is reduced to 0 velocity in a frictionless process. Static pressure is the pressure exerted on the body when it remains at rest. So static means it is the point at rest. So static, no motion. So static pressure is the pressure exerted on the body when it remains at rest. So from diagram, we can see there stagnation head equal to, there's a rise of liquid level plus static head. So you can see there stagnation pressure, stagnation head, we are balancing head here. Stagnation head equal to small letter h plus static head. So you can write h stagnation equal to small letter h plus h static. So there's a balance. You have to remember that stagnation head equal to h plus static head. So velocity of flow in a pipe by pitot tube. So there are many arrangements to measure velocity. For finding velocity at any point in a pipe by pitot tube, the following arrangements are adapted. Pitot tube along with vertical piezometer as shown in figure. So piezometer, I discussed about piezometer in chapter 1, that is in pressure measurement. So piezometer, that is used to measure the pressure. So it is a combination of piezometer tube and pitot tube. When velocity becomes 0, kinetic energy is 0 and pressure energy increases. As a result, there is liquid level rise by small letter h. So by knowing small letter h, we can calculate velocity. By knowing velocity, we can calculate discharge. So pitot tube connected with piezometer tube as shown in figure B. So first case pitot tube and piezometer was separate. Here in second case we are going to combine pitot tube and piezometer together. Same way we can get the rise of liquid level, that is H in pitot tube. So third case, pitot tube and vertical piezometer tube connected with differential U-tube manometer as shown in figure. So we are going to connect in third case the pitot tube, then piezometer and U-tube. So U-tube, that is going to measure rise of liquid level, that is small letter x. So by knowing small letter x, we can calculate small letter h. By knowing small letter h, we can calculate velocity. By knowing velocity, we can calculate discharge. The fourth case, pitot tube, which consists of two circular concentric tubes, one inside the other with some annular space in between as shown in figure D. The outlet of these tubes are connected to differential manometer, where difference of pressure head H is measured by knowing difference of levels of manometer liquid, say X. Then H equal to X into SH divided by SO minus 1. So SH is specific gravity of manometric fluid, SO is specific gravity of flowing fluid, and X, it is the rise of liquid, manometric liquid in U-tube. So you can see the arrangement. The pitot tube consists of two concentric tubes and with the some annular space left in between, and those are connected to U-tube manometer. So U-tube manometer, that is going to measure rise of liquid level, that is small letter x. So by knowing small letter x, we can calculate small letter h. So let's go for problem. First problem, pitot static tube placed in center of 300 mm pipeline has one orifice opening or orifice pointing upstream and other perpendicular to it. The mean velocity in the pipe is 0.80 of the central velocity. Find the discharge through pipe if the pressure difference between two orifices is 60 mm of water. Take coefficient of pitot tube as CV equal to 0.98. So this is the first problem. There is the pitot tube is placed at the center of 300 mm pipeline, that is small letter d equal to 300 mm, that is diameter of pipe. So the mean velocity in the pipe is 0.80 of the central velocity. Central velocity is capital letter V equal to CV into square root of 2gh. So mean velocity or average velocity equal to, we are going to represent it as V bar. So V bar equal to 0.80 times capital letter V. So 0.80 into central velocity. It is given in problem. So find the discharge through the pipe if the pressure difference between two orifices is 60 mm of water. So we are supposed to find capital letter Q, that is discharge, when pressure difference between two orifices is 60 mm of water. So what is pressure difference between two orifices? This is small letter H. Don't get confused with small letter X. There is no manometer here in this case. So it is small letter H. So small letter H, or it's the differential head. It is given in question. The pressure difference between two orifices is 60 mm of water. So 60 mm of flowing fluid is water. So it is given 60 mm of water. Take coefficient of pitot tube as CV equal to 0.98. CV equal to 0.98. Solution, diameter of pipe D, small letter d equal to 300 mm. So that is equal to 300 divided by 1000. So that is equal to 0.30 meter. Difference of pressure head, that is small letter h, equal to 60 mm of water, or that is equal to 60 divided by 1000 meter of water, or that is equal to 0.06 meter of water. CV equal to 0.98, mean velocity V bar equal to 0.80 into central velocity. But central velocity is given by V equal to CV into square root of 2gh. So 0.98 into square root of 2 into 9.81 into 0.06 equal to 1.063 meter per second. Now V bar, that is mean velocity, that is equal to 0.80 into central velocity. So that is equal to 0.80 into central velocity is 1.063. So 0.80 into 1.063, that is equal to 0.8504 meter per second. Therefore discharge Q equal to area of pipe into V bar. So that is equal to pi by 4 d square into V bar. So that is equal to pi by 4 into 0.3 square, that is the area of cross section, into 0.8504, that is equal to 0.06 meter cube per second. So in discharge you are supposed to consider mean velocity if it is given in question. So you have to consider mean velocity, area of the pipe into mean velocity. By knowing mean velocity we can calculate discharge. So Q equal to 0.06 meter cube per second. That is the value of discharge. So second problem, find the velocity of flow of an oil through a pipe when the difference of mercury level in differential U-tube manometer connected to two tappings of the pitot tube is 100 mm. Take coefficient of pitot tube as 0.98 and specific gravity of oil equal to 0.8. So here it is a combination of pitot tube and differential U-tube manometer. So U-tube manometer that reads the value x equal to 100 mm. This is not small letter h. In previous problem, you can see there is no manometer. So I have to take that as small letter h, or that is given in question pressure difference. Here in second problem, there is a differential U-tube manometer. So that reads x, small letter x, that is equal to 100 mm. So CV equal to 0.98, specific gravity of oil, that is SO equal to 0.8, because it's a flowing fluid, specific gravity of flowing fluid, SO equal to 0.8. So SH equal to 13.6. Solution, difference of mercury level, a small letter x equal to 100 mm, that is equal to 0.1 meter. Specific gravity of oil, SO equal to 0.8. Specific gravity of mercury, SH equal to 13.6, CV equal to 0.98. Difference of pressure head, H equal to X into SH divided by SO minus 1. Because specific gravity of manometric fluid is greater than specific gravity of flowing fluid. So that is 13.6 is greater than 0.8. So that is equal to H equal to 0.1 into 13.6 divided by 0.8 minus 1. So that is equal to 1.6 meter of flowing fluid. The flowing fluid here it is oil. So 1.6 meter of oil. So velocity of flow V equal to, there is a central velocity V equal to CV into square root of 2GH. So that is equal to 0.98 into square root of 2 into 9.81 into 1.6. That is equal to 5.60 meter per second. There is a central velocity. They told to calculate velocity. So there is a solution for second problem. So third problem, a pitot tube is used to measure the velocity of water in a pipe. The stagnation pressure head is 6 meter and static pressure head is 5 meter. Calculate the velocity of flow assuming coefficient of tube equal to 0.98. So velocity of flow, pitot tube is used to measure velocity of flow. The stagnation pressure head is 6 meter. That is H stagnation equal to 6 meter, H static equal to 5 meter. So we have to get a small letter h from H stagnation and H static. So that is, there is a correlation, H stagnation equal to H plus H static. So a small letter h equal to H stagnation minus H static. So 6 minus 5. So H value is small letter h equal to 1 meter. Solution, stagnation pressure head Hs equal to 6 meter. Static pressure head, you can use symbol as static pressure head HT, or you can write H static and H stagnation. That's left to you. Static pressure head HT equal to 5 meter. Therefore H equal to Hs minus HT, that is equal to 6 minus 5, that is equal to 1 meter. Therefore velocity of flow, that is central velocity V equal to CV into square root of 2GH, that is equal to 0.98 into square root of 2 into 9.81 into 1, that is equal to 4.34 meter per second. You have to remember one expression here, H stagnation equal to small letter h plus H static. So by using H stagnation and H static, you are supposed to find small letter h. By knowing small letter h, you can calculate velocity. Next, fourth problem, a submarine moves horizontally in sea and has its axis 50 centimeter below the 15 meter below the surface of water. A pitot tube properly placed just in front of the submarine and along its axis is connected to two limbs of U-tube containing mercury. The difference of mercury level is found to be 170 millimeter. Find the speed of submarine knowing that the specific gravity of mercury is 13.6 and that of sea water is 1.026 with respect to fresh water. This problem is very important. So the solution is like this. Submarine moves horizontally in a sea and its axis 15 meter below the surface of water. A pitot tube properly placed just in front of the submarine and along its axis is connected to two limbs of U-tube manometer. There is a U-tube manometer. The difference of mercury level is found to be 170 mm. That is small letter x equal to 170 mm. Find the speed of submarine knowing that specific gravity of mercury is 13.6, that is SH equal to 13.6, and that of sea water is 1.026 with respect to that of fresh water. Fresh water specific gravity is 1. So sea water specific gravity, that is SO equal to 1.026 into 1. So that is equal to 1.026. So solution, difference in mercury level, that is small letter x equal to 170 mm. So that is equal to 0.17 meter. So specific gravity of seawater SO equal to 1.026 into specific gravity of fresh water. Fresh water it is 1. So 1.026 into 1, that is equal to 1.026. So specific gravity of mercury SH equal to 13.6. Velocity of flow for pitot tube is given by capital letter V equal to CV into square root of 2GH. But small letter h equal to x into SH divided by SO minus 1. So because specific gravity of mercury is greater than specific gravity of flowing fluid, that is seawater. So SH divided by SO minus 1. So that is equal to 0.17 into 13.6 divided by 1.026 minus 1. That is equal to 2.0834 meter. Assuming as CV value it is not given in problem, you can directly assume CV value equal to 0.99 or 0.98, or you can directly assume it as 1. So it is better to assume CV equal to 1 because it is not given. So assuming CV equal to 1, V equal to CV into square root of 2GH, that is equal to 1 into square root of 2 into 9.81 into 2.0834, that is equal to 6.393 meter per second. So you can convert this meter per second to kilometer per hour, because submarine and all they are going to measure velocity or speed in kilometer per hour. So that can be done like this: 6.393 into 60 into 60, that is 1 hour, divided by 1000 to get in kilometer. So 6.393 divided by 1000 means it is kilometer. So in order to get hour, 1 second is 1 divided by 3600 R. So 1 divided by 3600, that goes to numerator. So 6.393 into 60 into 60 divided by 1000 equal to 23.01 kilometer per hour. I again repeat, to convert to kilometer per hour, so first convert meter to kilometer. That can be done by dividing 1000. 6.393 divided by 1000. So now 1 second is 1 divided by 3600 R. So because 1 hour equal to 3600 second, so just cross multiply. 1 second is how much? So upon that we are going to get 1 divided by 3600 in denominator. So 3600 goes to numerator. So 6.393 into 60 into 60, or 3600 divided by 1000 equal to 23.01 kilometer per hour. So that's the velocity. Last problem. A pitot tube is inserted in a pipe of 300 mm diameter. The static pressure in a pipe is 100 mm of mercury, that is vacuum. The stagnation pressure at the center of pipe recorded by pitot tube is 0.981 Newton per centimeter square. Calculate the rate of flow of water through pipe. If the mean velocity of flow is 0.85 times the central velocity, take CV equal to 0.98. So there's a pipe of diameter 300 mm. So that is D equal to 300 mm, or that is equal to 0.3 meter. Static pressure in a pipe. So it is 100 mm of mercury. H static it is given as 100 mm of mercury, that is vacuum. So it is minus 100 mm of mercury. So the stagnation pressure at the center of pipe recorded by pitot tube is 0.981 Newton per centimeter square. Stagnation pressure is given, so you have to calculate stagnation pressure head. Calculate the rate of flow of water through pipe. So that is Q. If the mean velocity of flow is 0.85 times central velocity, V bar equal to 0.85 into V. Take CV equal to 0.98. So solution, diameter of pipe, small letter d equal to 300 mm. So that is equal to 0.30 meter. Area equal to pi by 4 d square. So that is equal to pi by 4 into 0.3 square. So that is equal to 0.07068 meter square. Static pressure head, that is equal to 100 mm of mercury. So that is vacuum. So static pressure head, I already used this type of a sentence in a venturimeter problem. Static pressure head, it is given 100 mm of mercury. That is static pressure divided by rho mg. It is not rho g because it is given in terms of mercury. So static pressure divided by rho mg. So that is the static pressure head. So that is equal to minus 100. So in order to convert from millimeter to meter, you have to divide by 1000. So minus 100 divided by 1000. So that is equal to minus 0.1 meter. Now static pressure equal to minus 0.1 into 13,600 into 9.81. Just cross multiplying rho mg to other side. So rho m value, it is density of mercury, it is 13,600. So minus 0.1 into 13,600 into 9.81. So that is equal to minus 13,341.6 Newton per meter square. Now static pressure head in meter of water. Here you have to express in terms of meter of water, or you have to express such a way that it should be divided by rho g. So here, so flowing fluid, here it is water. So you have to express in terms of head of water. So static pressure head in meter of water, so that is equal to static pressure divided by rho g. So static pressure we got as the minus 13,341.6 divided by density of water, that is 1000, into g is acceleration due to gravity, that is 9.81. So 13,000 minus 13,341.6 divided by 1000 into 9.81, that is equal to minus 1.36 meter. So stagnation pressure, it is given 0.981 Newton per centimeter square. So convert from Newton per centimeter square to Newton per meter square just by multiplying 10 to the power 4. So 0.981 into 10 to the power 4 Newton per meter square. Therefore stagnation pressure head, that is equal to 0.981 into 10 to the power 4 divided by rho g. It is the stagnation pressure head. So I have to divide by rho g. So rho is of water. So because flowing fluid here water. So 0.981 into 10 to the power 4 divided by 1000 into 9.81. So that is equal to 1 meter. Now from correlation, H equal to stagnation pressure head minus static pressure head. Stagnation pressure head is 1.0. Static pressure head is minus 1.36. So 1.0 minus of 1.36, so it becomes positive. So 1 plus 1.36, so that is equal to 2.36 meter of flowing fluid. Flowing fluid, here it is water, so 2.36 meter of water. Now velocity at center is given by V equal to CV into square root of 2gh. So h value it is known, CV it is given, so g we know 9.81, so we can calculate central velocity. V equal to 0.98 into square root of 2 into 9.81 into 2.36. So that is equal to 6.668 meter per second. Now once we get the central velocity, we can calculate mean velocity because correlation is given in problem. So that is mean velocity equal to 0.85 times central velocity. So V bar equal to 0.85 into 6.668, that is equal to 5.6678 meter per second. That is the mean velocity. Now discharge Q, that is equal to area of the pipe into V bar. So that is V bar is center, this is mean velocity. So area of pipe, you can directly substitute here pi by 4 d square. Otherwise you can separately calculate area of cross section and you can substitute here. So I already calculated area, so I can just directly substitute here. So that is equal to discharge equal to 0.07068 into 5.6678, that is equal to 0.4006 meter cube per second. That's the discharge value. So this problem is similar to previous problem, but here the static pressure head, it is given in terms of mercury. So flowing fluid is water, so I have to first get static pressure, that is P static, then you have to divide P static divided by rho g. So you are going to get static head, so H static, and stagnation pressure is given. From stagnation pressure to get stagnation pressure head, that is by dividing pressure by rho g. So first in static head, it is given in terms of mercury, just get pressure. Then it is similar to your stagnation pressure, you have to just divide it by rho g, so that you are going to get static pressure head and stagnation pressure head. By using that you can calculate rise of liquid. So then you can calculate central velocity. By using central velocity you can calculate mean velocity. By using mean velocity you can calculate discharge. So these problems are very important from examination point of view. Just concentrate on these problems. Okay, thank you.